Hello students, in first lecture of more concept, we have studied about gram atomic mass, what is atomic mass unit, and what is mass of one atom and mass of one mole of atoms. So we have discussed that part. In this lecture, we are starting with laws of chemical composition. And first one is law of conservation of mass.
First one is law of conservation of mass.
Okay, what is law of conservation of mass? Matter can neither be created nor be destroyed. Simply, it is matter can neither be created nor be destroyed. Means during a chemical change, the matter remains conserved. There is one condition: the system should be a closed system. Like what I am saying is, if we have 12 grams of carbon and it combines with some amount of O2, I'm writing it as 32, we are going to get 44 grams of CO2. What is the meaning of closed system? This reaction must take place inside a closed chamber. Means, if you take an open vessel and burn carbon in presence of oxygen, the CO2 is going to get away as it is gas. If we burn carbon in presence of oxygen, the CO2 will go away because it is a gas. And to avoid that, we have to close the system. And now the mass will remain conserved. The mass of this whole system will remain same when we burn carbon. We are going to get 44 grams of CO. So this is simply law of conservation of mass. Though according to Einstein, this law fails miserably due to the fact that E is equal to mc square. But that will not be discussed here. Because of this part, let me just tell you that mass can be converted into energy according to Einstein, and it's valid for nuclear reaction, but for general reactions, the law of conservation of mass holds true. Law of definite proportion states that irrespective of the source, a compound contains the elements in same ratio of their masses. Like if we take river water, tap water, or distilled water. Water will contain same composition of H2 and O. Means mass of oxygen will be 16, mass of hydrogen will be 2. The ratio will remain same, 1 is to 8. So this is law of definite proportion. Irrespective of the source, the compound will contain same ratio of mass of elements. Like in case of CO2 also we can discuss. In case of CO2 or CO2 is not a good example. We can take atmospheric CO2 or from exhaust, vehicle exhaust. Thus, if we take CO2, both CO2s will contain same ratio of masses of elements, such as carbon will contain mass of 12 grams and oxygen will contain. The ratio will look like this. It will not contain such mass, but the ratio will be like this, and we can conclude the ratio will be 3 is to 8. So ratio will look like this, correct? The next one is law of multiple proportion. Law of multiple proportion is very simple. If two elements are combining and forming two or more compounds, such as sulfur and oxygen can combine in two ways. They can either form SO2 or SO3. So as I was telling, that sulfur is combining with oxygen in two ways. Either it is forming SO2 or SO3. We can simply say if I take 32 grams of sulfur, it can combine with either first, in this case, 32 grams of sulfur can combine with 32 grams of oxygen, and in this case 32 grams of sulfur will combine with 48 grams of oxygen. Okay, now we have to take constant mass of one element. Means in this case means in the case of law of multiple proportion, we have to take constant mass of one element. In both the cases we are taking same mass of sulfur, so mass of one element is constant, that is for sulfur the mass is constant. Now we have to check what is the ratio of masses of the other element. Like in this case, it is coming as 32 and this one is coming as 48. And if you conclude, it will come as 2 ratio 3. So the ratio will come as simple whole number ratio. And it is correct. It is coming as 2 is to 3. This is a simple ratio. This is not coming in points. So that's correct. We can simply say that constant mass of one element will combine with some mass of the other element in both the compounds, and those masses will be in simple ratio, and that is looking correct. So the definition of law of reciprocal proportion states that when two elements combine separately with fixed mass of third element, the ratio of their masses in which they do so is either same or some whole number multiple of ratio in which they combine with each other. Though the statement looks very typical, so I'm just trying to explain it. Like carbon is combining with oxygen to form CO2. The mass of carbon utilized is 12 grams. The mass of oxygen is 32 and CO2 is 40. Carbon is also combining with sulfur. 64 gram of sulfur combined with 12 gram of carbon to form CH2. Now, oxygen is combining with carbon, sulfur is also combining with carbon. You can see oxygen and sulfur is both are combining separately with the third element carbon in ratio 32 is to 64. Okay, 32 is to 64. And they both are combining with each other in the ratio 32 is to 32. So we can simply say that this ratio will also be simple whole number ratio. This will come as 2 is to 1. So it's a simple ratio. It's a simple ratio. Now we are moving to one more concept, that is density. What is density? Density, you are going to simply say it is mass by volume. But it is not very simple because there are types of density. This density is also known as absolute density. So what are the other types? There are relative densities. There is relative density, and in case of relative density, it can be specific gravity. Specific gravity. What is specific gravity? Specific gravity is equal to absolute density, absolute density divided by density of water at 4 degrees Celsius. So what is absolute density? So what is specific gravity? Absolute density by density of water at 4 degrees Celsius. As you all know, density of water at 4 degrees Celsius is equal to 1 gram per ml or centimeter cube or gram per centimeter cube. Okay, so its value is 1. What is the absolute density? Absolute density is XYZ. I am taking it as X gram per centimeter cube. So what is the use of specific gravity? Why we are using specific gravity instead of density? If we are dividing some number by 1 only, then what is the use of using this name, specific gravity? We can directly use absolute density. There is a logic behind it. We can remove the unit because specific gravity is a relative thing, we can simply remove the unit, because if we divide x by 1 gram per centimeter cube, the units will cancel out and we are going to get a number as value. So this number will be known as specific gravity. Specific gravity is unitless, while the absolute density had a unit. It can be gram per centimeter cube or kilogram per meter cube. It can be anything, but it will have some unit absolute density, while specific gravity will not have any unit. There is relative density with respect to hydrogen, or with respect to methane, or with respect to anything. You just have to divide by that density. If I take density with respect to hydrogen, I have to divide by a number of 2, because mass of hydrogen gas is 2. So I have to divide absolute density by a number of 2 to get density with respect to hydrogen gas. In case of density with respect to methane gas, we have to divide by a number of 16, because mass of methane is 16. Is that okay? Let me just write specifically with respect to methane. It will come as absolute density divided by density of methane. With respect to hydrogen, in case of with respect to hydrogen, we have to divide absolute density by density of hydrogen. Again, I am returning to my topic, that is mole. Now I am going to tell you formula of mole. Mole is mass of mass. Simply you can simply write down mass divided by molar mass. It can be gram atomic mass, molar mass can be gram atomic mass, gram molecular mass, or mass of 1 mole of anything, that is molar mass. Okay, mass divided by molar mass is known as number of moles. I am just taking a simple example. What is the number of moles in 48 gram of oxygen? We have to find out number of moles of oxygen atoms. Okay, number of moles of oxygen atom in 48 gram of oxygen. We can simply say 48 divided by what is the molar mass of oxygen? Oxygen is represented like this: O18, O8 and 16. So the molar mass of oxygen is 16, and we are going to get 3 moles of oxygen atoms. Okay, but in place of this, can we calculate number of moles of oxygen molecules? So what is the formula of oxygen molecule? That is O2. What is the mass of O2? That is 32. So number of moles in this case will be 48 divided by 32, that is 1.5. Is that correct? We are getting number of moles is equal to 1.5 in this case. But in previous case we were getting 3 moles of oxygen atom. In this case we are getting 1.5 molecules of O2. Okay. So you are going to say, sir, same 48 gram of oxygen, how it can contain 3 moles of oxygen atom and 1.5 moles of O2? So let me say this by taking example of family. Okay, in a family of 4, there is a mother, father, son and daughter-in-law. Okay, in a family of 4, there is son, father and mother and daughter-in-law. If we say how many females are there, sorry, if we say how many members are there, they are going to be 4. But if we say how many couples are there, they will be 2. So basically, the number of moles depends on which thing we are counting. In this case, we were counting number of oxygen atoms. If we count number of protons, it will be much higher because oxygen contains 8 protons, so it will be 3 times 8, means 24 moles of protons. While if we calculate number of oxygen molecules, because in case of oxygen molecule, we coupled two oxygen atoms to form a molecule, we are going to only get 1.5 moles of oxygen molecules. Okay, is that correct? So the next concept is volume in terms of moles. So 1 mole of any gas, mole of gas at 760 mm of Hg and 0 degree Celsius will have a volume of 22.4 liters. I am not writing this as STP because STP conditions are different. STP conditions will contain 750 mm of Hg and 0 degree Celsius. So this is not STP conditions, but in case of these are not STP conditions, but at these conditions the volume of gas will be 22.4 liters. Okay, how we determine that? We determine this experimentally. There is no conclusion made theoretically. This conclusion is experimental. That's why I am not explaining this part. Though you can calculate it by using PV is equal to nRT. Okay, PV is equal to nRT. You must have studied in class 9, and we are using that concept to determine the volume of one mole of gas. There is one more formula. In case of PV is equal to nRT. N is number of moles. You must be knowing that N represents number of moles. Its unit is, the unit of mole is also mole, but E will be missing. In this case, E will not be there. Unit of mole is mole. Okay? E will not be there. PV is equal to nRT. We can replace this formula here. PV is equal to M by mW, that is molar weight, RT. Can I say this like P into mW is equal to M by V RT, and this will become P into mW is equal to DRT. That's how we can convert PV is equal to nRT into density part. This formula will be used in many numericals, so you must know how we are driving this formula. You need not to memorize everything, because in case of memorizing, you are going to have a lot of formulas in chemistry if you memorize everything. If you memorize everything, so avoid that. Try to learn the concept. It will take some time, but we can learn the concept easily. We know the volume of 1 mole of gas, we know formula of mole, we know unit of mole. Also, we know P is equal to nRT. We are again going to discuss that. So you are given with one. So I am giving you one numerical. Calculate volume of gas having molar mass 46 and total mass of 230 grams at NTP. NTP, you just have to take volume is equal to 20.4 liters. Okay. Just try to calculate it. First, we are going to find out number of moles of the gas. Number of moles of gas will be mass divided by molar mass, mW. So it will come as 230 divided by 46. Okay. So it will come as 2 and 5. Okay. 2, 10, then 5. So 5 moles of this gas will be contained in this chamber. What is the volume of this 5 mole of gas? Volume of 5 moles of gas is equal to 5 into 22.4. You can calculate, it will come as 0 to 1. 5, 10, 11. Okay. It will come as 112.0. Is that okay? So that's how we can calculate volume. Next question is rather unusual. You have to calculate number of electrons in 49 grams of H3PO4. Just think about it. First thing that comes into mind, you are going to say that we can simply divide this weight by 9.1 into 10 to the power minus 31 kg. Means we are dividing total weight by mass of one electron. Can we calculate number of electrons from this part? No, we cannot, because all the mass of 49 grams does not contain electrons. It will contain some electrons, but all the mass is not made of electrons. It also contains protons, neutrons, so we have to consider that mass also. So how we can calculate? We can use number of moles concept. First we can calculate how many electrons are present in 1 mole of H3PO4. Then we can calculate in 49 grams how many moles of H3PO4 are there. First we can calculate how many electrons are there in 1 mole of H3PO4. Then we can calculate how many moles of H3PO4 are there in 49 grams of H3PO4. And finally we can calculate how many number of electrons are there in 49 grams of H3PO4. So simply we are going to start with H3PO4. One molecule of H3PO4 will contain how many electrons of H3PO4 is equal to how many electrons. So you can check that hydrogen contains 1 electron, 1 into 3, as hydrogen contains 1 electron. Phosphorus contains how many electrons? 31 electrons. So plus 31. And oxygen contains 16 electrons. So 16 into 4. 16 into 4. We are going to get 98 electrons in 1 molecule of H3PO4. Okay, there are 98 electrons in 1 molecule of H3PO4. 1 mole of H3PO4 will contain 1 mole of H3PO4 will contain 98 into 6.022 into 10 raised to power 23 electrons. Is that okay? Because 1 mole of H3PO4 will have 6.022 into 10 raised to power 23 molecules. Okay, and this much molecules will contain 98 into 6.022 into 10 raised to power 23 electrons. We can simply write it as this number as Na, that is Avogadro's number. Avogadro's number. Okay. So it will be equal to 98 Na electrons. That's okay. Now we have to check in 49 gram of H3PO4 how many moles of H3PO4 are there. So I can simply say mass by molecular mass will give us number of moles. So it will be 49. What is the molecular mass of H3PO4? It comes as 98. So the result will be half mole, 0.5 mole. So we are having 0.5 mole of H3PO4 and 1 mole of H3PO4 contains this much electrons. So half mole will contain, we can divide it by 2, 98 divided by 0.5 into Na electrons. That is equal to 46 Na electrons. That is also equal to 46 into 6.022 into 10 raised to power 23 electrons. Is that okay? I have calculated this very easily. I have opened each and every step. You can just see and try on your own again. So that's how we are going to solve this kind of numerical. I am going to take few more examples in the next lecture.